Okay, so good morning again, class. Right now, alam niyo na kung paano mag-solve ng soil-bearing capacity using the Terzaghi equation and using the modified Terzaghi equation. So, the soil-bearing capacity itself is uh, uh, very important in designing foundation. So, kahit man mag deep foundation or shallow foundation, the soil bearing capacity is very important. Okay? Nakikita nyo ba yung ano nakikita nyo sa screen ko? Full screen ba? Yung full screen ba ng ano?
Opo, sir.
Okay. Ayan. So, ayun, that is the soil bearing capacity. Okay? So, you can use the modified Terzaghi or you can use yung Terzaghi itself, okay? Then, in the modified Terzaghi, the equation of bearing factors can be derived using the equation of Prandtl, using the equation of Vesic, okay? And yung NC, NQ, and gamma. Okay, you can derive that equation. So basically, yung unang define ni Terzaghi na bearing factors is modified by means of research. Okay, and ayan, kaya then nag-introduce sila ng iba't ibang factors, yung shape factor, depth factor, and inclination factor. Okay. So, depends on the given situation if bibigyan ko kayo ng problem na using the Terzaghi equation or using the modified Terzaghi equations. Okay? So, again, the soil bearing capacity is one of the most important parameters in designing foundations. Okay, so right now we will design an isolated footing under uniform pressure using the Nscp 2015. Uniform pressure means you have actually loaded column. Okay, that is the assumption. Meaning there is no moment. Okay, there is no moment, and your actual load or compression actual load is basically acting on the centroid of your column. Okay, that is our assumption. Okay, sige. Then an isolated footing, or sometimes they call this as a single column footing, and also meron ding tinatawag nila na pad footing. Okay. Nawala yung screen. Okay. Wait lang, class ha. Hello class, alam niyo ba yung settings na ano? Mapupunta sa akin yung full view. Ayaw eh.
Pag zoom po ata sir, full view po ata talaga sir.
Nagiging ano siya eh, nagiging presenter view. Nakikita niyo ba to? Wait. Ito, yan. Nagiging ganyan. Alam niyo ba paano bumalik dun sa ano? Post ko lang yung record. Okay, so this is an example detail of isolated or a single column footing. So sometimes they call this one as a pad footing. Okay. It is used to support the load of a single column. These are the most commonly used footing, particularly where the loads are relatively light and the columns are not closely spaced. Okay, so this type of foundation is typically used for low rise or sometimes a mid-rise project, a mid-rise building project. Okay, so this is an example of rebar detailing of isolated footing. Okay, so you have a footing pad. Okay, you have a reinforcement. Okay, at the bottom, so along the X and along the Y. Okay, you have a hook length at the ends. Okay, you can see your column stirrups, the column rebar. Okay, and it should be okay. Dapat meron itong naka-hook din dapat siya dito. Anyway, sometimes they are using this detail, but yung pinaka common is to use yung hook at the ends of your column. Okay? So, ang makikita nyo sa mga plano in structural plans is just like this one. Okay, ang minsan depends kasi sa style nung format ng plans. Okay, sometimes ang makikita niyo sa plans is naka-drawing lang yung footing, then you have your rebar, then meron siyang spacing na ganyan. And sometimes meron naman naka-table. Okay, yung nakikita niyo na naka-table. So let's say this one, you have diameter 12 at 200 mm spacing on center. Okay, so ang nakalagay dito is footing rebar detail along X. Yan, yung mga nakalagay dyan. Yan. Okay. Sometimes they're using this yung paglagay sa plano, and sometimes naka table. Okay? So as you can see, katulad nito, okay, meron siyang cover. Okay, you will need to secure spacer or yung tinatawag nila na block, okay? Spacer block, okay, at least 3 inches or 75 millimeters. Okay, so this is an example of designing isolated and strap footing. So a pad footing with footing tie beam. So basically the strap footing is like an isolated footing with a footing tie beam. Okay, a quick question. Bakit kailangan mo maglagay ng footing tie beam when you have a column or you have an isolated footing na yung column is nandun sa edge? Okay, so anong ibig ko sabihin? If you have a footing, okay, so ganito, then your column is located at the ends. Okay, so bakit nagkakaroon ng column na nasa ends? Why? Because the client wants to maximize, the lot area, okay? However, hindi siya pwedeng maghukay ng foundation dun sa outside of his lot area. Okay, so bawal 'yon. So kunwari ito yung lot area mo. Then you want to maximize your lot area, so dito ka naglagay ng poste sa ends, 'di ba? May sa ends ka. So bawal kang maghukay ng foundation doon sa kabilang lot kasi gusto mo maging actually loaded siya, 'di ba? So you cannot create your foundation outside of your lot. So ang nangyayari is magkakaroon siya ng overly eccentric na isolated footing. Okay? So ang mangyayari, magkakaroon ng overturning moment dun sa inyong foundations. Okay? You have an overturning moment in your foundation. So when you have an actual load dito, aangat to. For example, you don't have this footing tie beam. So the tendency of this footing pad is to overturn. So aangat yung kabilang side, aangat ito, then ito is magko-compression. Okay? And please take note that soil subgrade, okay, cannot resist tension. Okay? Always compression siya. So when you have an overturning moment concrete padding, so the tendency is magkakaroon ng settlement. Okay? Magkakaroon ng failure. Okay? So therefore, the solution is to provide, okay, to provide a footing tie beam just like this one. So the footing tie beam is by the word itself is is to tie your footing to another isolated footing by means of a beam. Okay. Sorry. So the tendency, since you provided a tie beam dito, okay? So the tendency is hindi na to aangat yung side na to. Okay? This side will not cause tension, okay? Will not overturn because you provided an footing tie beam, okay? So in this detail, you can see the soil pressure in your soil, okay? So you can see you have this one. So when you are designing an isolated footing or any footing, you need to check the soil bearing capacity of your soil and compare your actual soil pressure to your soil bearing capacity. Okay, then your actual should have a factor of safety and also considering the allowable settlement. Okay, then use a load combinations to determine. So this is a service load combination. So that is the process of designing an isolated footing or any footing. Just check the soil pressure, check compare it to the soil bearing capacity, check the displacement. If you lumagpas ka dun sa allowable settlement conducted by the geotechnical engineer. Okay, so let us consider muna yung designing an isolated footing under actually loaded column or under the assumptions of a uniform pressure. Okay, yung actual soil pressure or the soil pressure at the surface of contact between the footing and the soil is assumed to be uniformly distributed as the load above is applied at the center of the gravity. Okay, and also known as the actually loaded footing. Okay, so ang actually loaded footing, ibig sabihin, this is your footing pad. Okay, so get the centroid. So centroid is this one. Dapat yung centroid of your footing is coinciding to the centroid of your column. So your column must be placed over here. Okay. So that is an isolated, actually loaded footing. Okay. So how to determine the actual soil pressure? So to determine the actual soil pressure is you have your pressure, okay? So you have your isolated footing. So this is the section view of your isolated footing. Then you applied an actual load. Okay, the assumption is that actual load will cause a uniform pressure at the bottom of your footing. Okay, so the allowable soil pressures is the allowable soil bearing capacity. Okay, so right now you can now solve for the allowable soil bearing capacity. Okay, so the allowable soil bearing capacity to be used for designing the footing for a particular structure are desirably obtained by the geotechnical engineer. So based on the section given by the ACI code, so the footing, the required area of footing is to be determined by dividing the anticipated load, including the footing weight, by a permissible soil pressure using a principle of soil mechanics. It will be noted that this total load is the unfactor load and yet design of footing based on the strength design. So ano ibig sabihin nito? You need to design your required area of your footing, okay, by comparing it to the allowable soil bearing capacity, okay, considering the footing weight and the permissible soil pressure. And please take note that your total load must be unfactored or ibig sabihin, okay, using the strength design. Okay? So, ano ba yung strength design? Naalala niyo ba yung strength design? The strength design is basically yung first load combination is that is dead load, total dead load. Another load combination is dead load plus live load. Okay? So yan yung yan yung strength design or yung unfactored load. Okay? So you can check the load combinations in Nscp 2015. Okay? So, in designing, we can first assume the soil bearing capacity kung wala pa yung geotechnical report. Okay? So, we can first, syempre, hindi nyo kung hindi nyo alam, in structural engineering or in civil engineering, let's say, hectic yung schedule lang dyan palagi eh. Okay? So, for example, si geotechnical engineer hindi pa tapos mag-conduct ng geotechnical report ng soil bearing capacity and you need to start your preliminary design. Okay? So, ang gagawin mo, you need to first assume the soil bearing capacity of your foundation para maka-conduct ka ng preliminary design. Okay? So, the maximum allowable soil pressure depends on the class of material is can be assumed using this table. Okay, for rock, you can use 20% of the ultimate crushing strength. For compact coarse sand, compact fine sand, hard sand, or sand clay, you can use 385 kPa or 8 kips per square feet. Okay, so in medium stiff clay or sandy clay, you can use 290 kPa. Compact inorganic sand silt mixture, you can use 190 kPa. For a loose sand class material, you can use 145 kPa. A soft sand or clay, you can use 95 kPa. Loose inorganic sand silt, you can use 50 kPa. And loose organic sand silt or muck or bay mud, ibig sabihin hindi ka pwede dyan mag-design. Okay, because sobrang loose niya na. Okay, then marami pa siyang organic materials. Okay, then no, almost putik na siya or bay mud. Okay, you cannot hindi yan ina-allow to have a structure above. Okay, so these are the assumptions. Your first assumption for the preliminary sizes. Okay, but this assumption must be verified by the report of the geotechnical engineer. Okay? So, according to kanina, sabi niya, the size of the footing or the required area should be based from the unfactored loads. Okay? But you need to consider the footing weight and the permissible soil bearing capacity. Okay? So therefore, the required area for a concentrically loaded footings is determined from area required is equals to dead plus live load, divided by Q sub E, where Q sub E is the net allowable soil bearing capacity. Your QA is allowable pressure, QE is effective or sometimes permissible or sometimes they call it net soil pressure, and D and L are the unfactored dead and live loads. Okay? So the allowable bearing pressure Q sub A under service loads are usually based on the factor of safety of 2.5 to 3. Okay? So ang binibigay sa atin ni geotechnical engineer na soil bearing capacity should have a factor of safety of 2.5 or 3. Okay? 2.5 to 3. Okay? So this required area footings under the effect of wind or earthquake is determined from the following. So if you have a lateral load, if your analysis, during your analysis, you determine that you have your governing lateral or governing lateral load, maybe wind or earthquake. So your load combinations should be dead load plus live load plus wind, or pwede kang dead load plus live load plus E over 1.4. Okay? And according to the Nscp, if you have a lateral loads, you can increase your soil bearing capacity by 4 over 3 or 1.333. Okay. So therefore, the soil bearing capacity, the allowable soil bearing capacity is 1.33 QE. Okay? Kaya may siya 1.33 QE. So paano ba yung QE na yan? Okay? Yung Q sub E, okay, this is very important. Your Q sub E is the effective permissible soil pressure, or sometimes they call this a net soil pressure, is equals to Q sub A minus unit weight of concrete times the thickness of your footing minus the unit weight of the soil times the height of the soil minus the surcharge load. Okay? So basically, so paano nangyari yan? Bakit may net? Okay, so for example, this is your isolated footing and you have uh, a soil above. Okay, may soil tayo above. Then you have a surcharge load. This is your QS. Okay, let's say this one. You have a surcharge load. This is QS. And this is the soil bearing capacity as allowable. Let's say call it as Q sub A. Okay. Then you have a unit weight of concrete and a unit weight of soil. Okay. So therefore, by means of equilibrium, ang tanging may iwan, the net pressure to accommodate the additional loads, okay, to accommodate the additional load of this axial load, let's say dead load and live load, earthquake, or this axial load or axial compression is the net of this soil bearing this pressure. Okay, so if we consider this one, i-consider natin yan, okay, you have your QA, this is your yung unang binigay sa inyo ni geotechnical engineer na soil bearing capacity minus the pressure due to concrete. Okay, what is the pressure due to concrete? So basically this is your HC, height of concrete, is gamma C minus H multiplied by HC, okay, minus the unit weight due to the pressure due to soil. Okay, the pressure due to soil. So this is the height of the soil. Okay, so they have unit weight of the soil, height of the soil. Okay, minus the surcharge load at the top. So this is Q sub E. This is the only pressure that is magkokontra dun sa pressure due to your axial load. So therefore, we need to design always, okay, we need to always design our axial compression based on this Q sub E. Okay, again, this Q sub E is yung natitira from the allowable pressure minus the pressure due to concrete minus pressure due to your soil minus the surcharge load or any surcharge load. Yun lang yung tanging magre-resist to this axial compression. Okay? So in an isolated analysis of isolated footing, we are assuming a condition of uniform soil pressure. Okay? So you have your dapat pantay. Okay, you have a an actually loaded compression. Okay, and the assumption is the pressure at the bottom is uniform. Okay. So therefore, the deformed shape of this one is just like this one. So ano yung makikita nyo dito? Just like a simply supported beam with uniformly distributed load. Okay. So therefore, you have a shear diagram just like this one. At the ends, you have zero moments. Okay, zero moments, increasing your shear. Okay. Then also the moment diagram is just like this one. Okay. So you have your shear diagram, you have your moment diagram based on the assumption of uniform soil pressure. Okay. So there are the way to design your isolated footing. You need to check your shear. Okay, you need to check your moments. Sometimes you need to check your your settlement or deflection in normal beam situation. So this one is your settlement. Okay, so you need to check your shear, your moments, and your settlement. Okay, so let us go for the shear. So the shear in footings, or shear in footings under the assumption of uniform pressure, is divided into two. You have your one-way shear and your two-way shear. Okay, the one-way shear, sometimes they call it a wide beam shear, and the two-way shear, they call it as punching shear. Okay, so pag-aralan natin isa-isa. So for the wide beam or one-way shear action, wide beam shear or one-way shear action is you have a just like your beam. If you recall the beam, kung nakapag RCD kayo, di ba? So the way we design our shear designing is we need to find the shear the D distance from the ends. Okay, if you recall, you have your D distance, dun siya mag-form ng crack. This will form the crack. Okay, this V sub U is your V designing, and you need to design your beam based on the shear force at the D distance from the support. So you have different conditions kung kailan ka magdi-D distance or or nandun lang sa supports. Okay, but most cases is D distance from the support because based on research, based on laboratory, they noticed that the first cracking occurs at the D distance from the face of the support. What is the D distance? D distance is the effective depth distance. Okay, so you have your effective depth. Okay, you have your actual load. You will form a cracking. Okay, this one will cause cracking. Okay, so that is the D distance from the face of the support. So your support now is the column. Okay, you will deform your shape, okay, at this portion. So you can assume that at this portion you have a rigid connection. Okay, in this portion you have a rigid connection, or your moment rotation is equals to 0. Okay, so we can assume that at this portion you have a support. Okay, so kaya in wide beam shear, okay, in wide beam shear meron tayong tinatawag na D distance at sa isang side and D distance on the other side. Okay, so ganito yung case if you have different if you have a rectangular isolated footing. Okay, so you can have this area, you can analyze this area, and you can also analyze this area. Okay, so you will choose the largest area. Okay, you will choose the largest area. Okay, that largest area is the governing area that will resist this wide beam or one-way shear action. Okay, sige, tingnan natin yung pressure sa ilalim para mas madali nyo maintindihan. So if you check the pressure at the bottom, okay, kunin natin tong area na to ha. Kunin natin yung area na to. So this is your XW, you have your effective depth D, and you have your B distance. Okay, yung B distance, let's say this one is your B distance. Okay, so naintindihan nyo ba? Nakikita nyo ba yung cut na to? Okay, this one. Okay, you have your B, you have your XW notation, you have your effective depth D. Okay. So kapag meron kang soil pressure, so uniform pressure at the bottom, okay, this will be your shearing area. So ito yung shearing area na sinasabi. This will be your shearing area, right? This one. Yan yung shearing area. Okay? So just like this one, ito yung shearing area niya. Then, since the assumption, okay, based on the assumption that you have a uniform pressure, okay, just like this one, you have a uniform pressure. So dito analysis lang to class ha. This is analysis ha. Analysis. So meaning lahat ng forces dito is based on the loads in elastic analysis kung manual computation or using software. Okay, so this is analysis. So you have your actual load PU. Okay, so your soil pressure is equals to Q sub U is equals to PU over area. Okay, force over area, your area of your footing. Okay, you have your Q sub U. So kung kukunin natin tong portion na to, syempre meron pa rin pressure yan sa ilalim, di ba? You have your QU. Okay? Therefore, your B sub U, okay, with subscript W is meaning you have your shear force on wide beam shear or one-way shear action is equals to, okay, ano sa tingin nyo? Okay, kukunin nyo yung area sa ilalim multiplied by the pressure. Okay, so therefore you have your Q sub U multiplied by XW times B distance. Okay, yan yung pressure, yan yung force na magko-cause ng shearing area dun sa side na yon. Okay, so again that is VU sub W is equals to Q sub U times your XW times your B distance. So kukunin nyo lang yung area ng pressure sa ilalim multiplied by the pressure, meron ka ng load. Okay. Then, if we consider the stress on that shearing area, okay, that is equals to tau sub W is equals to VU sub W over ano yung area na to? Yung area ng shearing area, that is B times D, right? Your B times D. And since we are designing in ACI, if you recall, or in Nscp, okay, you have a factor phi. Okay, that factor phi is equals to 0.75 in Nscp 2015. And that phi is equals to 0.85 in Nscp 2001. So please forget na lang yung 2001 since we are not designing in 2001. So therefore, your phi should be 0.75. Okay, and the shear capacity of concrete, if you recall, the shear capacity of concrete is equals to shear stress. The shear stress capacity of concrete is equals to 0.17 your factor lambda multiplied by the square root of F prime of C, or the compressive strength of your concrete. Okay, so to determine if your foundation is able to resist that actual load PU, is you need to compare the actual shear stress, okay, versus the actual capacity. Okay. So demand versus the capacity. Okay, so this is a one-way beam or a one-way shear action. There is another shear stresses in an isolated footing, and they call it as a punching or a two-way shear action. Okay, by the word itself, punching is the tendency of the column. Okay, the actual load in the column, the tendency is ipapunch niya yung foundation. Okay, so ipapunch, by the word itself, punch, iti-tear apart niya yung foundation, yung concrete, yung foundation pad. Okay, so this part tends to punch out. Yan yung scenario when you have a punching or a two-way shear failure. Okay, so the assumption for a punching shear or a two-way shear action is it will happen at a d over 2 distance from the face of the column. Okay, or 1/2 of the effective depth from the face of the column. So the critical area is this location. Okay, this location, this, and this location. Okay, so kung titingnan nyo yan in 3D view, para yung nag-punch out yung kabila. Okay, na ganito. Okay. So ito yung nangyari dun sa column mo. Okay, let's say ito yung footing. Okay. Yung column, sorry. Your column. Okay, yan. This is your column and yung outside is yung inyong yung na tear out. Okay. Yan. Okay. Yan. Yeah. I hope nakikita niyo siya. Okay, yan. Yan. Okay. May drawing yata ako dito. So anyway, so yan yung nakita dun sa column. Okay, ito yung magpa-punch out in 3D view. Okay. So that is the tendency. So ito yung bali this one is d over 2 plus d over 2 plus the column width. So let's say this one is cx and this one is yung cy. Okay. Then itong side na to, so this is your cx and itong side na to is your d over 2 plus d over 2 plus cy. Yeah, yan yung distance na yan. So that is the tendency of punching or a two-way shear action. So katulad lang din ng kanina is you need first to determine kung ano yung mga dimensions. So itong dimensions na to, let's say this is distance C sub 2 and distance C sub 1. Okay. Therefore, this perimeter of the critical area or critical section is basically equals to C sub 2 plus D over 2 plus D over 2 is equals to effective depth D. And yung isang side is C1 plus D over 2 plus D over 2, that is C1 plus D. Okay. So this area, okay, yung area na to, this area is the area that we need to consider. Okay. Pwede rin yung sa loob, but mas madaling gawin yung dito sa labas. Okay, yung area na yan. Okay. So kapag na-determine natin yung area na yan, multiply it to your Q sub U, okay, you will get your shear force that will cause punching. Okay? So kunin natin siya. Yan. Kunin natin yung area sa loob, yung green area. Itong green, yung perimeter, yung nasa loob lang. Okay, yung green na to. Kunin natin. Yung that distance is C2 plus D and C1 plus D. Tama? Okay. Then, this area, this shaded region is the area that is resisting for two-way shear action or this punching shear action. Yung area na yan. Yan yung magkakos ng shear, yung magkikiskisan doon sa na-tear na part. Okay? Yan yung ito. If you check, ito siya. Yan yung assumption, parang meron ka lang dito. Okay, kinulay nila dito. Yan, this one and this one. Okay. This is that area. Okay, so with reference to the figure, shearing area is the gray area. Okay, so your B sub O is the perimeter of the shearing area. Okay, so how to determine your V sub U P? Okay, so your V sub UP should be, okay, hindi ko siya nasulat. Your V sub U sub P or the V sub UP is equals to your Q sub U, okay, multiplied by the area of your footing. Okay, so yung this shaded red area, okay, yung red area na yan. So that is basically the, let's say ito ay B and this one is your L. Okay, that is equals to B times L minus C1 plus D, C2 plus D. Okay? So, ibig sabihin, kunin lang natin yung area na yan. Paano ba kunin yung area na yan? Di ba, basically, that is BL minus yung area ng itong loob na yan, di ba? Area sa labas minus yung area sa loob, yun yung area na red part. Yan yung kailangan natin. So, B times L minus C1 plus T times C2 plus T. Okay? So, therefore, that Q sub U times that area is equals to your actual shear force that will cause punching in your foundation. And if you want to check for the stresses, okay, kung gusto nyo kunin yung stresses, so you have your force divided by this shearing area. Ilan ba yung shearing area na yan? Okay. So you have your area 1, area 2, area 3, okay? Or and area 4, or pwede nyo gawin, kunin nyo yung perimeter multiplied by the height D. Okay? So yan yung paano makukuha yung shearing area na yan. So B sub O is the perimeter of your shearing area. So basically C1 plus D times 2 plus C2 times D times 2. Okay, meron ka ng perimeter. Then multiplied mo by the distance, yan yung area. So that is why your shear stress in punching is equals to V sub U sub P divided by phi or resistance factor, that is 0.75. Okay, your B sub O is the perimeter of your shearing area multiplied by the effective depth D. Okay, and this one is the Nscp table, okay, based on the allowable two-way shear stress V sub C. Okay. Okay, in Nscp 2015, ang reference niya lang is ACI 318-11. Okay, ACI 318-11. Okay. However, in the ACI 318-19, okay, ibig sabihin, if you know that the Nscp is based on the American Concrete Institute. Okay. So 318-19 siya. So for two-way members without shear reinforcement, they use phi sub c is equals to 0.33 lambda s times lambda square root of f prime c. Okay, VC is 0.17 multiplied by 1 plus 2 over beta C lambda S or times lambda square root of F prime C. And your VC is equals to 0.083 plus 2 times AS, okay, times D over B sub O multiplied by lambda times square root of F prime C. Okay. Take note, in the ACI 318-19, okay, ang nadagdag lang dito class is this one, yung lambda S, the size modification factor, this lambda S. Okay. So if you check the Nscp 2015, they have the same formula. Okay. Ang nagbago lang is yung meron ka ng size modification factor. And that size modification factor is equals to the square root of 2 over 1 plus 0.004 D. And that is equals, that should be less than or equal to 1.0. Okay. And the value of your AS is equals to 40 for interior columns and 30 for the edge columns and 20 for corner columns. Okay. This one, yung VS na to. So, in your case, during the exam, okay, or during the mga practice problems, okay, you will not consider this lambda S, okay, the size modification factor. So, if you want to check the Nscp 2015, they have the same value, okay, wala lang yung size modification factor. And this beta sub C is equals to the ratio of the long side to short side of your column. Okay, so let's say short sides of the column concentrated or reaction area. Okay, so yan yung beta C, the ratio of the long to short sides of the column. So for example, you have 250 by 500. Okay, therefore 500 divided by 250. Yan yung column dimensions mo. Okay, and also we have another limit states in designing in designing isolated footing is what they call the moment, flexure, and bending, or moment, flexure, bending. Okay, in the moment or a flexural bending action, okay, the critical area is at the face of your column. Okay, take note, at the face of your column. So you have your X distance. So ito na lang yung kinuha ko since this is the largest area. But if you can't determine the largest area, can check this one, yung isang side na to, and compare sino yung may largest area. Yung largest area will give you the critical part kapag magkaiba sila ng dimensions. Okay. So if we get this area, this region, that is X times B times D. X distance, B distance, and effective depth, D. Okay. And you have your soil uniform pressure. Okay. Your uniform pressure is Q sub U, that is PU divided by area of your footing. Okay. So titingnan natin siya on this side. Okay, if we check on this side, yan, check natin this on this side. So kita mo yung Q sub U doon. And okay, you have your bending over here. Okay, bakit magkakaroon ng bending dyan? Okay, considering this strip, let's consider ilang strip pa. Let us consider let's say ganito. Okay, itong strip lang na to. dx. Let's say dz distance. So consider lang natin yung dz distance. Okay. Then since the assumption is this region, okay, is very rigid and you cannot hindi mo kayang ma-deform yung columns, so we can assume this one as an cantilever beam. Okay, so kung di ba, if you recall, cantilever beam with load Q sub U, yung deform shape is just like this one. So i-rotate nyo lang yan, ganyan yung itsura niya. Okay, so therefore you have a moment at the face of your column and that is your M sub U. Yan yung kailangan mo during your design. And what is the moment of a cantilever beam with uniformly distributed load? That is equals to Q sub U multiplied by B distance. Okay, the total B distance. Yan yung B distance siya along the length. Okay, if you consider lahat na, if you consider mo lahat, that is B distance all throughout the length. Okay, and therefore meron ka ng uniformly distributed load. Okay, meron ka ng uniformly distributed load. You have your pressure times B distance, UDL na yan. That is kilonewton per meter. Okay, so multiplied mo na siya by X, then times centroidal distance X over 2. So therefore, you have your MU. Okay, and if you recall in designing a beam, just like designing a beam, your MU is equals to ASFY D minus A over 2 multiplied by resistance factor phi. And your resistance factor phi is equals to 0.9. Okay, so yan yung pag-solve for the AS. Now, to find the distribution of flexural reinforcement, so the designer may select a rectangular or a square isolated footing. However, a square footing is normally desirable because it will require less material and will be simpler to construct because of the same dimensions of B and L. Okay, so the depth of the footing will be required based on the two-way or one-way shear actions, and the additional dito is the steel area or the area of steel is based on the moments. Again, the footing depth, okay, the depth of the footing is based on two-way or one-way shear actions, and the flexural reinforcement or the area of the steel is based on the flexural bending. Okay, so typically one-way shear will be very often controls the depth for rectangular footing, whereas the two-way shear action normally controls the depth of the square footing. Okay, so for square footing, the reinforcing in short and long direction may be equally spaced because of the simplicity of the design, since they have the same the same distance on B and L. But such is not the case for a rectangular footing in short span direction. Okay, so for example, you have your isolated footing, which is rectangular. Okay, so according to the Nscp, uh, you can equally space your reinforcement on a square footing, but it is not the case for a rectangular footing. Okay, so you need to consider this bandwidth. Okay, this bandwidth is equals to the B distance, yan. And you need to find uh, factor, what you call this, okay, this factor, what you call, omega s, or not, that is not omega, what you call this one, psi sub s. Okay, that is equals to the ratio of the reinforcing in bandwidth, okay, the reinforcement on this area, this bandwidth, divided by the total as in the short direction. Okay, and that is also equals to 2 over beta plus 1, that is less than or equal to 1.0, whereas your beta is the long side of the footing divided by the short side of the footing. Okay, and yan yung ilalagay nyo dito sa bandwidth. Okay, and dun sa other side, okay, yung dito sa may bandwidth, kasi critical yung part na to eh. So sa this critical part, you will distribute your AS by a factor of this one. Okay? And yan yung ilalatag mo dito. Yan. Along short eh. Yan yung ilalatag mo dyan. Na, okay. So, mas concentrated in the bandwidth area compared dun sa other sides. Okay. So therefore, on the other sides, okay, so 100% minus factor multiplied by AS. Okay, that is the total distribution on the on the sides. Okay, then divided by 2. So yan yung reinforcement at this region and this region. Yan yung distribution on each side. Okay, so again, yung total AS mo na na-solve kanina will be distributed to along the bandwidth and outside the bandwidth. Okay, your reinforcement for a rectangular footing is distributed to bandwidth and outside bandwidth, and within the bandwidth, the short span reinforcing within the bandwidth should have mas marami compared to the outside bandwidth. So therefore, your AS is in the bandwidth should be distributed by a factor. Okay, and on the other side, on the outside of the bandwidth, you were 100% of your AS minus the factor divided by 2 multiplied by AS. That is the reinforcement on each outside of the bandwidth. Okay. So, ibig sabihin lang nito, dun sa bandwidth kasi critical yung region na yun, and therefore, kailangan natin magbigay ng mas maraming reinforcement. Okay, so in summary of our discussion, an isolated footing is assumed to be uniform pressure. Okay, under an actually loaded footing. Okay, then the area required is based on this equation. Okay, it should be noted that your Q sub E is equals to your soil bearing capacity minus the pressure due to concrete, pressure due to soil, and the surcharge load. The shearing area is equals to this one. Okay, this is for one-way shear, and you need to consider Q sub U is equals to PU times area. So take note, this is your analysis. And this one is yung demand. Your capacity, sorry. Capacity of concrete. And this one is the demand or the actual load. Then for a two-way shear action, this part will tend to punch out, and this will be your demand. Okay, this will be your demand. Your V sub U sub P, or yung shear VU sub P, is equals to your Q sub U multiplied by the difference of C1 of area of the footing minus C1 minus the product of C1 plus T and C2 plus T. Okay? And the capacity of a two-way shear is given by this one. So in Nscp 2015, the size modification factor is hindi pa siya existing. Okay, this is based on the ACI 318-19. So you will choose the minimum of these three values. And for moment, limit state is you have your moments. Okay, you have your QU. Your QU is the pressure that is equals to your P sub U divided by the area of your footing. And your MU is based on the assumption that this will cause an bending, okay, para siyang cantilever beam, okay, cantilever beam. And your AS is equals to MU over phi Fy d minus A over 2. And your phi is equals to 0.9 inch in bending, and your phi is equals to 0.75 in shear, either one way or two way shear. And for rectangular footing, you need to consider bandwidth. Okay, so this bandwidth area has a concentrated flexural reinforcement with factor with this factor, and on the other side is yung remaining. Okay, so yan. So next meeting na lang yung example problem in design of isolated footing under a uniform pressure. So if you want a heads up kung paano yung ano yung problem, so you can try to solve for this one. So your answer should be in the multiple choice. Okay? Sige class. So that's it for today, and thank you for listening.